lesson, we're going to be looking at the slopes of parallel and perpendicular lines. Let's first review what slope is and how we find it. We're going to look at slope from a graph. You have four examples up here. The first one is of a positive slope where it goes from lower left to upper right. We know that's positive. The second one is a negative slope. It goes from upper left to lower right. The third one is a horizontal line that has a slope of 0. And then the fourth one is a vertical line, and that is an undefined slope. It's also no slope, and it's actually not even a function, so it's undefined. So now let's calculate the slope from each one of these graphs. We find slope by rise over run. That also, you might have seen it as change in y over change in x. So the first thing I'm going to do is find a point on this graph, and I'm going to go up 1 and over 2 to the next point. Then I go up 1 over 2 to the next point. So I'm rising 1 and I'm running 2. So the slope is positive 1 over 2. In example number 2, I'm going to do the same thing. I'm going to find 2 points on the graph. These 2 points are the ones that I've written, and you find points where like they intersect two lines, so you can easily calculate. From here to there, I'm going to go down 2 and over 1, 2, 3. Rise over run. Vertical change is -2. Horizontal change is +3. So that's a slope of -2 over 3. The third one, the slope is just 0. And the fourth one, the slope is undefined. Okay. And I've written here also that in number 3, the slope of 0, all of the y values are the same. And then in number 4, with the slope of that's undefined, every point on this line, every x value is the same. So now let's review how to calculate slope from 2 points. We're going to use the slope formula. Slope is y2 minus y1 over x2 minus x1. And so that formula calculates the change in the y values, right? I'm subtracting over the change in the x values. So, and this is like number 5, slope of line AB. This is how you might see it in geometry. This is a geometry lesson. So the slope of line AB can be calculated from these 2 points. Point A, the location is 14.3, and point B, the location is 0.7. So the first thing I'm going to do is label x1, y1, and x2, y2. So in one point, if that's x1, I'm labeling that y value y1. And now I'm going to plug it into my slope formula. M equals 7 minus 3 over 0 minus 14. 7 minus 3 is 4. 0 minus 14 is -14. And then I'm going to simplify it. It's just a fraction. I can divide my numerator and denominator by 2. It simplifies to -2 over 7. Let's look at number 6. The slope of line CD with these points, I'm going to label x1, y1, and x2, y2. And then I'm going to plug it into my slope formula and solve. So m is -2 minus 7 over -12 minus, be careful here, -8. Look what that looks like. -12 minus -8, which is really like -12 plus 8. And I have students that just go ahead and write that down. And now I'm going to simplify it. -2 minus 7 is -9. -12 minus -8, which is like -12 plus 8, is -4. And that can simplify to 9 over 4. Looking at number 7, the slope of line EF with these points are x1, y1, x2, y2. Now I'm going to plug it into my slope formula. That looks like this. And if you labeled this one x2, y2, and this one x1, y1, that's totally fine. It really doesn't matter. Just know that whatever you label x1, its y value is y1. So 16 minus 0 over 25 minus 25. And in this case, I get 16 over 0. So what's the slope? The slope is undefined. You cannot have 0 in your denominator. So this is an example of an undefined slope. And wouldn't it make sense that this x value is the same as this x value? And if I were to graph those 2 points on the coordinate plane, it would be a vertical line, just like this. Now let's look at number 8, the slope of line GH. G has a point of negative 10, 17. H has a point of negative 12, negative 13. And I went ahead and labeled this one x2, y2, and x1, y1 just to show you that it doesn't matter what you label x1, y1, and x2, y2, but the whole point needs to be like the same. Like if that's x2, that's y2, right? If that's x1, that's y1. And now I'm going to plug that into my slope formula. 17 minus negative 13. Be careful there, right? The formula you're subtracting. So 17 minus negative 13, that's like the same thing as 17 plus 13. Then negative 10 minus negative 12. All of that simplifies to 30 over 2, which simplifies to 15. Let's move on. The slope of parallel lines. Slopes of parallel lines are the same. They're exactly the same. They have the same rise over run. An example of that would be if you have a slope of a line that's 1/4, the slope of a line that's parallel to it is also going to be 1/4. So in 9 through 12, the directions say line CD is parallel to line AB. Find the slope of line CD if A and B are located at. Okay, so I'm going to find the slope of each of these lines, and I know that line CD is going to have that same slope because it's parallel to line AB. So let's use our slope formula. In the first one, I didn't label, I just did 7 minus 4 over 8 minus 4. If you need to label, please continue to do so. And if I'm going too fast for you, pause the video, rewind it, whatever you need to do. So now I'm going to simplify. 7 minus 4 is 3. 8 minus 4 is 4. The slope of line CD is going to be 3 over 4. And look how I wrote that. The slope of line CD equals 3, 4. If you wanted to write M of line CD, with a symbol over it, equals 3/4, you could do that as well. This is just shorthand, but that's what that means. Looking at number 10, I'm going to do the same thing. I'm going to take those points, plug it into my slope formula. I did 6 minus 4 over negative 8 minus 5. That simplifies to 2 over negative 3, which means the slope of line CD is going to be negative 2/3. Number 11, same thing. Let's plug it into our slope formula. If you want to pause the video and try it yourself, I would encourage you to do that now. Here it is plugged in. I did 12 minus 2 over negative 10 minus negative 8. That simplifies to 10 over negative 2, which simplifies to negative 5. So the slope of line CD, which is parallel to line AB, is going to also be negative 5. Number 12, let's plug it into our slope formula. Negative 6 minus negative 3 over 4 minus 4. Simplified, that comes out to negative 3 over 0. Can I have 0 in the denominator? No, that's an undefined slope, which means the slope of a line that's parallel to this line will also be undefined. Moving on, let's look at the slope of perpendicular lines. Perpendicular lines, the slopes, are opposite reciprocals. Well, what's that? An example of that would be if you have a slope of a line that's 3/4, a slope of a line that's perpendicular to that would be, I got to flip it and I take the opposite. So it's going to be negative, and then I flip my numerator and denominator and I get 4/3. So let's do the same thing with 13 through 16, but we're going to be finding a slope because the example says, and let me read the directions here, sorry, getting ahead of myself. Line EF is perpendicular to line GH. Find the slope of line GH if E and F are located at. So let's find the slope of each line, and then we're going to find the slope of the line that's perpendicular to it. Again, I'm going to plug these points into my slope formula, and I get 12 minus 11 over -7 minus -9. That simplifies to 1/2. So if the slope of this line is 1/2, then the slope of the line that's perpendicular to it is going to be what? I got to flip it and take the opposite. So the slope of line GH is going to be -2/1, which is just -2. Let's move on to number 14. I'm going to plug those points into my slope formula. -15 minus -3 over 10 minus 8. I'm going to simplify it, and I get -12/2. Simplified further, I get -6. So if the slope of line EF is -6, then the slope of line GH, which is perpendicular to it, is going to be what? I'm going to flip it and take the opposite. Remember, -6 is just -6/1. So when I flip it and take the opposite, I get positive, flipped, 1/6. So the slope of line GH is 1/6. Last two examples. Number 15, let's plug it into our slope formula. 6 minus 6 over -9 minus 4. That comes out to 0 over -13. Can I have 0 in the numerator? Sure. 0 divided by -13 is just 0. So let's think about that. The slope of this line is 0. That's horizontal. What would be the slope of the line that's perpendicular to that? Well, the slope of a line that's perpendicular to a horizontal line, that's a vertical line. What's the slope of a vertical line? It is undefined. So the slope in this case would be undefined. So I went ahead, if you want to pause the video and write this down, this is the slope of a horizontal line. A perpendicular line would be vertical. I went ahead and drew a picture. Visuals are really great. Horizontal line, vertical line, slope of this line is undefined. Last example, let's plug these points into our slope formula. And this, I went the opposite direction, -8 minus 6 over 7 minus -5. That simplifies to -14 over 12, which simplifies to -7/6. What would be the slope of the line that's perpendicular to this line? So switch it and flip it. Take the opposite of the negative and then switch the numerator and denominator. So the slope of line GH in this case would be +6/7. All right, last examples for this set of notes. Okay, we're going to decide if these lines are parallel, perpendicular, or neither. They could just be intersecting, right? So I've got all these points on the coordinate plane A, B, C, D, E, F, and G. We're going to use these points that are part of each of these lines to determine if these are parallel, perpendicular, or neither. And just to reiterate, parallel lines have the same slope. Perpendicular lines are opposite reciprocals. And I've got the little symbols there used for each one of these. So number 17, we need to decide line AB and line DE, how they are, if they're parallel, perpendicular, or neither. So first, let's look at line AB, and I'm going to kind of write everything down at once. Line AB, the slope of line AB, I'm looking here, is 5 minus 2 over 7 minus 16, which simplifies to 3 over negative 9, which simplifies to negative 1/3. Now I'm looking at line DE. These are the 2 points I'm going to use in my slope formula. And I decided to do 20 minus 8 over negative 3 minus negative 7. That simplifies to 12 over 4, which simplifies to 3. So how are these related? Are they parallel, perpendicular, or neither? They're perpendicular. They're opposite reciprocals of each other. So you have to find the slope of each line and then determine how are they related. And again, I just want to reiterate, it doesn't matter which way you go, like what you label x1, y1. Make sure that you're subtracting your y's in your numerator, that's on top, and then your x's are on bottom. Now we're looking at line BC and line EF. Line BC is going to look like this. I did negative 4 minus 5 over 15 minus 7, which simplifies to negative 9 over 8, and I can't simplify that anymore. Now let's look at line EF. That's over here. Here's my work for that one. 20 minus 6 over negative 3 minus 13, which simplifies to 14 over negative 16. And I can simplify that further by dividing both by 2 to get negative 7 over 8. So how are these two lines related? The slopes of them, that is. Are they the same? Are they opposite reciprocals? No, they're neither. So they're just neither. And if they're not parallel and they're not perpendicular, they're just going to be intersecting lines at some point. So last example, line CD and line BG. So C and D right here. Here's my work for that when I plug it into the slope formula. 8 minus negative 4 over negative 7 minus 15. That simplifies to 12 over negative 22, which simplifies to negative 6 over 11. Now let's do the work for BG. Line BG. I did 11 minus 5 over negative 3 minus 7, and I get negative 6 over 11. So how are these, or it looks like 6 over negative 11, but isn't that the same thing as just negative 6 over 11? It is. So now I have slopes, lines with slopes that are the same, which means they are parallel lines. And that concludes your notes over the slopes of parallel and perpendicular lines. I hope it was helpful.